Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning and to all my classmates and Mr. Wong. Today, me and my friend Zulhusni are going to present about motion in dynamics. I am Yahya Suwaid Yahya Muhammad with matric number 175747. I am an engineering and mechanical engineering student in UPN. And this is my friend Zulhusni. Next slide. I want to tell you that all the information given in this presentation are taken from the book, Mechanics for Engineering Dynamics, 13th edition by Hebler and Kevin Yap. What is going to be looked on in this presentation? Actually, there are 4 points that are going to be looked on. First, interesting facts about motion in dynamics. Second is our daily life from physical point of view. And then we are going to speak about an understanding of the general concept of dynamics and the motion in dynamics. And then the different types of motions with some examples for each motion. First of all, what is dynamics? What is motion? Dynamics actually is a branch of physics in which it is concentrated more about forces and torque. Some of you who doesn't know physics or dynamics would ask me, what is torque? I would answer that torque is the rotational force. Let me take one example. This picture, the ice skating picture, we can see that they are making a slope. For this slope to be completed well, knowledge of dynamics must be applied in order to know the speed to accomplish this move. Moreover, dynamics is used in making cars and the well-known game Angry Birds. What is motion? Motion is the change in place with its reference point. That is the first, just like the introduction. Now I'm going to do the first point. First, my point. What is interesting facts about dynamics? What is the history of dynamics? Who is the inventor of dynamics? These are some questions everyone need to know in dynamics. First of all, Isaac Newton. Sir Isaac Newton is the one who did or invented dynamics, and he's the one who invented the 3 laws in motion. 3 laws of Newton in motion. It was first invented in the late 15th century and beginning of the 16th century. Although it has been a long time, these 3 laws are being used until now. The evolution of motion dynamics. Actually, when Isaac Newton invented the 3 laws, he was the first, like the pioneer point was the drop of the apple. It was a very short distance, but now there was a big jump from above the outlier. It was estimated that that jump was 39 kilometers, with the estimated speed 1,349 kilometers per hour, which means that the dynamics and motion dynamics has evolved a lot during this era. General concept of motion in dynamics. Actually, the first Newton law says every object contain constant or maintain constant unless there is a force is applied in it. If this force is applied in any object, then the velocity of the force of the object will change. which causes acceleration to occur, which is the second law. The second law, increase in velocity, is acceleration. The third law is that for every action there is a reaction. As for the action in the first law, it is the action is the force. The reaction is the change in the object direction. That's for my point. This for my part. I would like to make friends do his part.
Thank you to Yahya. So first of all, I want to introduce to you myself. My name is Muhammad Zulhusni Zulkifli, and I comes from Faculty of Science. So I will continue to the other slides, which is the motion in our daily life. So in front of you, we can see the slide which has the 4 pictures, which is throwing, falling, pushing, and lifting. So in this slide, I will mention to you about 6 types of motion. So the first motion is the linear motion, and the second motion is rotary motion. So what is the linear motion? Linear motion is the motion along the straight line, which can describe mathematically using only one spatial dimension. And the linear motion can be 2 types, which is uniform linear motion and non-uniform linear motion. In the uniform linear motion, it has the constant velocity and zero acceleration, while in the non-uniform linear motion, it has variable velocity and non-zero acceleration. So for the second motion, which is the rotary motion. Rotary motion is the rotation around a fixed axis, is a special case in a rotary motion. And according to the Euler theorem, Euler rotation theorem, simultaneous rotation along the number of stationary axis at the same time is impossible. And if 2 rotations are forced at the same time, a new axis of rotation will appear. So we go to the third motion, which is the reciprocal motion, and the fourth is simple harmonic motion. So for the reciprocal motion, the reciprocating motion is also called a reciprocated reciprocation. It's a repetitive up and down, back and forth linear motion, and it can found in a wide range of mechanisms, which is in the reciprocating engines and pumps. So for the simple harmonic motion is the type of periodic motion which the restoring force is directly proportional to the displacement. And simple harmonic motion can be shown by the motion of the mass of the spring when it is subject to the linear elastic restoring force can give by the Hooke's law, which you all know that Hooke's law is state that F equal to Kx, which the F is the force and X is the displacement, and F is directly proportional to the X. So for the fifth motion, it is the circular motion, and the sixth is the rolling motion. So for the circular motion, it's the movement of an object along a circumference. Movement of the object along the circumference of the circle of rotation along a circular path, and it can be uniform with a constant angular rate of rotation and constant speed, and non-uniform with a changing rate of rotation. So for the last motion is the rolling motion. The rolling is a type of motion that combines rotation and translation of the object with respect to the surface. And if ideal conditions exist, the two are in contact and with each other without sliding. So we go to the next slide, and the slide is tell us about the application of motion in daily life. So for the first motion is linear motion. So for the linear motion, we can give the example, which is the motion of train or a ball being thrown, or the motion of a roller coaster. So for the rotary motion, we can give about the 6 example, which is the LCD or DVD when playing, the turntable in a microwave oven, the figure skater in a spin, the turbine in a jet engine, a closed dryer running, and the last is the earth spinning answer day. So for the reciprocal motion, we can give the transport engine and the pump as a example. So for the simple harmonic motion, we can give the example is the motion of pendulum and clock. And the fifth motion, the circular motion, the example such as the motion of Earth in the system or the motion of a wheels. And for the last motion, which is the rolling motion, the two example that states in the slide is the motion of roller coasters, and the last is the motion of wheels in all transports. That's all for the slide, which tells us about the type of motion and its application for the each motion, which is I state that in the previous slide we have 6 motion, so we have 6 application that relate to the motion. So for the conclusion, motion is all involved in all application in daily life, which means that all that we doing, such as we walking, we throwing, we pushing, or something that we talk in simple words, we use the energy, we relate this to the motion. So for the second conclusion is motion are related to all branch of physics. If you taken the physics subject, you can know that everything in physics that we learn is relate to the motion, but not only one motion. We can have many motion, not only the 6 motion that in this slide. So that's all from me and Yahya. Thank you.